Hello everyone, and welcome to the Mat 211 review of the binomial distribution. My name is Julia, and I work for the tutoring centers at ASU. So, we have that x is a binomial variable with n equals 6 and p equals 0.5. And we want to find the probability that x is less than or equal to 5. So recall that when we have binomial trials or binomial distribution, so a variable from the binomial distribution, then the probability of being any specific value, so x equals some little x, which is a specific value that big X can take, then this is going to equal the binomial distribution, symbolized with this b, of n, little x, and p, which we can write out explicitly as n choose x times p to the little x times q to the n minus x power, where q is equal to 1 minus p. Recall also that n is going to be the total number of trials, which we're given here. X is the current target number that we're looking for big X to take on. And so we can think of this as like the number of successes, for instance. And then P is the probability of success, while Q over here is the probability of failure, which always has this relationship with X or with P, where Q is 1 minus P. So now let's think about what we want to solve here. We want to know the probability that x is less than or equal to 5. Now, because x can't be any smaller than 0, because you can't have a negative number for x since it's a number of successes. You can't have a negative number of successes in trials. You can only have failures, which means you don't count them. So the smallest number that our big X could take on here is equal to 0. So if we think of all the numbers here within 6 trials, our number of trials here, X could be, 0, 1, 2, 3, 4, 5, or 6, but it couldn't be anything else in this case. So if we want that x is less than or equal to 5, then we're looking for the range of numbers here from 0 to 5. So that's quite a few probabilities that we would need to calculate, because we would need to calculate the probability that x is equal to 0 using this full formula here, plus the probability that x is equal to 1, plus the probability that x is equal to 2, plus, and so on up until adding on the probability that x is equal to 5. So we'd have to calculate 1, x equals 1, x equals 0, plus x equals 1, plus x equals 2, plus x equals 3, plus x equals 4, and plus x equals 5, which is a bunch to calculate. However, also notice that there's only one value left here, the probability that x is equal to 6. And since this this set of numbers here is the full range of values that x can take, then we know that the probability that x is equal to 6 is going to be 1 minus the probability that x is equal to all of these other values. So x is less than or equal to 5, because it can only be one of these two conditions. It's either less than or equal to 5, or it's 6 in this case, since we're subsetting our possible events this way, our event space. So instead of calculating this, notice that we can rewrite this equation here so that we can all we have to do is calculate this guy. So what we want to know, notice that if we subtract this guy over to the left side and then subtract this guy over to the right side, well, we end up with, let's clear this and we'll just do it. See what we mean here. So say that we first subtract this guy over here. So that's going to give us, probability that x is less than or equal to 5, plus the probability that x is equal 6. Well, that equals 1, as expected. Then our probability that x is less than or equal to 5 is equal to 1 minus the probability that x is equal to 6. So what this tells us is that all we have to do is calculate this and subtract it from 1, which is much easier. So let's go ahead and do that. So first, we know that we're looking for the probability that x is equal to 6, and that's going to be equal to our binomial distribution here with n given to us as 6. Our little x here, well, that's going to be our 6 because that's our target number of successes. And p, which is given to us as 0.5. Which then that will equal 6, choose 6, times our p, which is 0.5. And we're going to say that that is to the 6th power, since that's our number of successes, times, well, we didn't calculate q as, q explicitly this time, but remember that it's equal to 1 minus p, so we could just say 1 minus p here, or in this case, 1 minus 0.5. But since we're saying that 6 out of 6 trials are successes, then our n minus x here, which is going to be 6 minus 6, is just equal to 0. So this is to the 0th power. So 6 choose 6 is going to equal 1. So we got 1 times 0.5 to the 6th times, well, we know that this is going to be 0.5 inside here because 1 minus 0.5 is still 0.5, but it's also to the 0th power, and anything to the 0th power is equal to 1. So we've got 1 times 0.5 to the 6th times 1. So all we have to do is figure out what 0.5 to the 6th is. And if we look in our calculator, we find that this is 0.015625. And let's get rid of that dot because it looks like a comma here. And make that a proper dot too. There we go. So now that we know what our probability of x is equal to 6 is, then we can look back at our calculation over here. So let's go ahead and do that. We'll erase this guy because we don't really need him anymore. And so we know that we want our probability that x is less than or equal to 5 is equal to 1 minus the probability that x is equal to 6, which is 1 minus this guy, 0.015625, which is equal to, let's see, I forgot to write that down calculated. Well, so this is equal to approximately 0.98. And you can do the specific math on your calculator if you want more decimals. So this is our answer to solving this, and that's it. So before I go, I just want to remind you all that if you're looking for any additional tutoring or academic support at ASU, please visit the Tutoring Center's website, tutoring.asu.edu, where you will find all of our resources. Also, if you're looking for tutoring services for your specific course, you can use our tutor search tool, which you can find on our main website here, or by going directly to the tool at this full link. So thanks so much and have a great rest of your day.